Today what I want to talk to you about is called the alphabet of lines. And what this is it is the lines that are commonly used in a blueprint. And since our class is about reading welding language in blueprints, we need to learn how to read an actual blueprint first. So these lines are common lines that you will see when you're looking at a blueprint. So what I have here is a blueprint that I made, which is why none of this stuff down here in the bottom is filled out. We'll go over this in a future class where I show you what goes into all of this and why it's important. So what we have here is a bunch of the common lines you'd see on a blueprint, and then we have a list over here. So the way I set this up is we'll have an arrow that points at the object that or the line we're looking at, the type. And over on this other side, you'll actually have an arrow that points at all the different features on the blueprint. So the first one we're going to look at is what's called a visible object line. And so these lines are the lines that are actually part of your feature. So this is an edge of this piece, right? So you can see over here that it's a rectangular piece, and this is the top view looking down at it, and this is one of the edges. All right, so those are your visible object lines. And so the next line we have is called the hidden line. And a hidden line is, you want to think about this piece, instead of being, say, made out of steel, or in this case cast iron, you want to think about it being made out of plexiglass, right? So this would be the view from this piece from this end, right? So if we were looking straight down this end, this is that view right here. And what you're seeing here with these hidden lines are actually the internal edges of this feature here and the internal edges of these holes here. So you can see these dotted lines here, and those are representing the internal features that we're showing here, okay? So think about when you're seeing hidden lines, think about it, it's like the piece is made out of plexiglass and you can see inside of it. And so you can see the features that would otherwise be obscured by the material. So our next line is our center lines. And our center lines are pretty self-explanatory. In this case, I have them drawn as, I have two center lines on here. I have this line that runs through the object this way, and I have a line that runs through the object this way. And there are these long dash, short dash, long dash, short dash lines. And in this case, they're showing not only the center of the object, but they're designating the center of this hole as well. And you can see that over here too. So even though this isn't center of the object, this is center of the hole. So we have a line that runs through here and a line that runs through here. And then these lines here that are bisecting this circle. And those are our center lines. Our next dimension that we're going to look at is what's called our dimension lines and our extension lines. So it's two sets. Our dimension line is this line right here, right? And it's got arrows on both sides and it's got a value here. So in this case, we're dealing with millimeters. And you have this line here that goes from your extension line to your extension line of where it's being measured. And these extension lines are basically, we're coming from the edge of our object, right? And we're extending it out so we can put a dimension line in without it being cluttered up on this piece. So if we were to put our dimension lines on, or our dimensions on all the pieces, you'd have all of this information would have to be crammed into this part. Instead, we can do extension lines off of the part and then do our dimension lines. And you'll notice that these are thinner than what we have for our visible object lines. So our visible object lines are a thicker, broader line. Our extension lines are going to be thinner. So that's a way that when you're looking at stuff, you can see that it's designated out. And we have a few of them here. So we have it being 300 millimeters across, 100 millimeters wide. From center to center on these holes, we have 100 millimeters. Over here, we know that the total piece height is 40 millimeters, and the width of this base material is 10. So these are all our dimension lines and our extension lines. So the next thing we'll look at is what's called a leader line. And a leader line is a line that comes out that has an arrow on it. And what this arrow is showing is that this is our diameter. You have a circle with a slash through it, so that's your designator for diameter. Our diameter of this outer circle where that arrow is pointing is 60 millimeters. This line, this leader line, is pointing at the inner circle, and we have diameter again. Diameter of the inner circle is 50 millimeters. These leader lines are pointing at the holes that are over here, and they're showing that they're a diameter of 20 millimeters. So our next one is a little bit more complicated, and what this is this is showing a broad line here. Back up. It's showing a broad line across here, and it's showing two directional arrows at that broad line. And what that is saying is that we're going to be cutting this piece in half along this line. So if you think about if we were putting a plane in here that was perpendicular to this part, so we're just sliding a piece of glass in that's infinitesimally skinny, just dropping it in, cutting the piece apart, and then that's going down here, and this is that piece cut in half and then flipped like you were looking at the cut. So this shows you some of your internal features. And in this case, we can see, because this piece is symmetric across this plane, we can see across the plane that we cut, we can see the center of both of our holes and this hole in the middle as well, and we can see how this dimensions works. And in the next slide, you'll get to see where some of this comes into play as well, as far as multiple pieces coming together, things along those lines when you're doing a cut plane. So this is our cutting plane, this broad line here with these arrows. So our next feature that we're going to look at is what's called section lines. And these are identifying internal feature lines. And in this case, we're looking at what is this single hash line on a diagonal is for cast iron. All the different materials will have different hashes for them, and you don't need to necessarily memorize those, but as we go through the class, you'll be able to see those. So say if you had a bronze bushing in here that was cut in half, it would have a different structure to it. Or if you had something that was stainless steel, or you had a rubber washer that was fitted, like an O-ring that was part of this that you were showing, it would have a different cross section to designate that it's not cast iron. Also, if you were to have another piece that came in and butted against it, we'll see this in the next piece, you might have different directional cross hashing to show that that's two separate pieces coming together that would be welded. So I didn't have any break lines on this drawing that I gave. I'll show you these guys in a little bit more detail in the next section. But really what these are looking at is we're looking at long break lines. Long break lines are going through the entire piece and separating it out. In some cases, you might have this because you have a whole nother piece that's over here that you don't want to be included in this blown up drawing. In other cases, it might be just so that you're showing that you have a greater distance in between here than that is represented by the scale. So you might have, if you were to put a measurement on here, from this edge to this edge, with this break line in there, you wouldn't want to be using that as a scale measurement because you know that this dimension is no longer to scale or accurate. It's just showing this piece is broken apart, and you know that on the other side of this break line, so say if you just were showing this side right here, on this other side, you have more of the piece. With our short break lines, you're seeing just a little squiggly line here, and you can see that this is a cutout. So we have a little small cutout here, right? And this is a short break line that shows that a piece is supposed to go there. And basically what they've done here is they've cut out this square of the piece, right? So you can see into the hole. Actually, I think it's this square right here. So you can see that there's a hole there with the center, and you can see what the material is. So that's a short break line. So it's not bisecting the whole piece. It's just going part way through and showing you that we're looking at some internal structure there. And then we have phantom lines. And phantom lines are, say in this case, we have an object that can rotate around a center point. And so we have our visible object lines are these solid lines right here. This is our object that we're seeing that's sitting flat and perpendicular to the sheet. And then we have our phantom lines showing that piece rotated around. And so everything that's not actually part of that original drawing is going to be put into the phantom lines, but it's all going to be accurate in representing that movement of that piece. All right, and so this is another blueprint. This one I pulled from the book I'm using, and this one shows all of those features again, and you can see why in some cases some of that stuff is really important. So you can see here that we have some center lines on our piece, right? And we also have in this case an internal radius. So to show where that radius is located off of for this internal radius on the circle, we draw in some center lines to give us a point for the center of that circle for our internal radius there. We also have a cut line here, and you can see here where we are looking at that cut line. Here it's designated by this dashed, really strong line with the arrows out with the A to A, and you can see here we have section AA, right? So AA, section AA. You can see in here that we have a different hash mark, and if we go over here, we can see that the material over here that this is made out of steel, right? So that hash mark is for steel, where the hash marks we were looking at before were cast iron. Some of the other features you see going on in here are, you can see that these arms that would be coming off, so if we bisected this along here, we can see that these arms coming off they're the same steel, but they're in a different orientation to this centerpiece. So that lets us know that these arms are actually separate pieces that are then welded on. And you can actually see the welding indicators here. We haven't talked about this yet, but you can see that these are indicators for that weld. These hash marks in here at an angle. And you can see up here you have another welding designation up here. So this is a leader line coming in, but it's showing welding information. So the weld bead that you're looking for in that case. You can also see that you have some phantom lines around here. These phantom lines are showing that you can have a little bit of variability in this piece. You have an allowance of run out. So say if you're welding this piece and it tips over a tiny bit before you do your machining, you have this allowance of run out. So if this piece was to say fit into a casing, there's this much slop in that casing that this wouldn't then be hitting the case that it's spinning in. So this is another use of phantom lines. So even though this isn't a rotating piece around a pivot point or anything like that, it's just showing where your allowance for your run out is. So that's a few examples of how this works. You can see here also in your cut that by doing a cut that runs down this piece, we can see what some of the internal structure looks like. So we know when it's being machined, how it needs to be machined. And a few things along those lines. So this is an example of what you might see in a class or what you might see in a job. This is a welded piece that is then machined afterwards. You have some notes here that talk about that. Anyway, that's what we've got for this week. I hope it was useful, and we'll talk to you guys later.